Hello, I was getting carried away making a little circuit today for the big synthesizer. One of the problems with the big synthesizer is when you plug in gates and things, you can't see physically what's happening. You can hear when something's working, but you don't get any visual feedback from it. So I kind of thought, if I have a little LED that sort of lights up when it detects a gate signal just above the jack socket or something, then I'm going to start getting some sort of visual feedback of things that I'm doing. And it looks pretty as well when you've got lots of LEDs flashing away on synthesizers. So I've put this little circuit together here. Now this little circuit will take 12 to 15 volts, and when you send in anything over a couple of volts, it'll light the LED. So I thought, great, there's a gate display. So then I thought I'll put it down onto a little circuit board and see what it looks like, and got all the components together. These are all the components, and then I suddenly had this wild idea of using the laser to see if I can actually cut circuit board. That's great, but it won't cut the holes through it, so they're no good. What about doing it with surface mount components? Now these are the equivalent surface mount components to these components here. I'm not too sure about the transistor. I made this little device here that I could attach my tester to, and I put a little transistor in the middle and sort of held it down, and I've got something close to the BC547 that's there, so it might work, it might not work, but at least I should be able to get the circuit figured out onto here and make it really, really tiny. And then if I can do it with the laser, then I could just run off loads and loads of them as I need them. The reason this is flashing away, by the way, is this is just the Vactrol circuitry. Now, a Vactrol is basically an LED and a light-dependent resistor. And as the light falls onto the light-dependent resistor, the resistance falls across these two pins. Now, the beauty of this is it's not instant. When the light goes out, this doesn't change instantly. There's a little bit of a delay. So that's why these have been used in the past for simple things like compressor circuits and low-pass gates even. So I'll be making something with this sort of Vactrol sometime in the future. Now this is a proper Vactrol. This is what they look like. And you always have one leg longer than the next leg. And that gives you the clue that this is the LED side of it. And this is the light-dependent resistor. And here is one I cut open earlier. As you can see, it's just an LED there and a light detector on the other side. So there you go. Chop that open just for the video. The laser that I have got is actually a marking laser. It isn't really a cutting laser. It's made specifically to mark metal. But I think if I set it high enough, I think it goes up to about 20 watts. If I set it high enough, it should vaporize the copper off this surface. But like I say, it won't cut a hole through that. So I'm going to try and design the circuitry here to work on a piece of copper, like so. Now the circuit for this, by the way, is really simple. And what you've basically got is a NPN transistor, okay? There's your collector, there's your base, and that's your emitter. So then what you'll have going off here is this will be where your gate signal would come in. So we'll put gate on there, okay? And try and work this out as I go along. So that would go to ground. And yeah, we'll probably need to add a resistor there as well. And then on the collector, you would go into a LED, and that's where you put your 12 volts in, okay? And so you put your 12 volts here, send in a gate signal, the transistor will switch on the LED and make it light up. So maybe put a capacitor across there as well, just for good look. And I've kind of found out that these should be about 100k, and this, depending on the LED, you can have anything from 1k to, I don't know, 15k, depending on if you use high brightness LEDs. And as you know, some blue LEDs and red LEDs, you know, they kind of need a different, they'll need a different resistor to light them correctly. So this was my transistor holder that I just made up with the 3 bits of copper tape, and I put my tester on these 3 pieces here, and then I just used a pencil with an eraser on the end to just slightly give that a little push to hold it in place while it did its test. So I've managed to find an NPN transistor that is sort of close to the BC547 but not exact, so I don't know if this thing will actually work. But like I say, the idea at the moment is just to see if the laser is going to cut a circuit board for me. The little surface mount transistor has a different pin out to the BC547. I'll find a pen that you'll be able to see on the camera here and explain. So on a BC547, if you looked at it from the bottom, like so, okay, and you've got your 3 pins. I think this is collector, this will be base, and this is emitter. So that's a BC547. Now this little surface mount dot transistor, there you go, I'm sure you can see that on camera. That's a little bit different. What happens with that is, if I do it like that, okay, so you've got 1 pin up there, and you've got 2 pins down below here. Now that's the collector, and this is the base, and this is the emitter. So I can't just make that circuit tiny and then stick all the components down onto it. I've got to jiggle them around already just to make sure everything lines up. So what I'm basically going to have to do is switch my brain on for a start, and maybe use, let me see, right, so we're going to have a gate. Alright, we're going to have a gate input. This is just going to be a pad on the board so that I can solder one of these things on the edge of it. Let me zoom in a bit so you can actually see what I'm writing. I'm sorry this isn't a very professional video here, it was just, I was just in the middle of doing something and decided I might share this. So we're going to have a pad for this pin to solder onto, and we want a 100k resistor on there. So the copper trace will have a break there, and this is going to be where the 100k resistor is. Okay, and then that's gonna, I've got another resistor there between that and the emitter, but hang on a minute, that's going to be the base. The base, right, okay, this isn't too bad. If I stick the transistor there, then this is going to connect to the base. If I extend that, so it's going to have to go through the 100k and into the base. Yeah, this is the copper here. Right. So we also need a resistor. You see that? Need a resistor between the ground and the emitter. Now the emitter's there, so that's okay. We can actually just drop one directly in there. So that's the other 100k. See? I'm just kind of making it in blocks. And that's going to be the ground. Okay, so the ground is going to go there. That's okay. Minus, I'll write it as a minus. So that's good. That's connected this to ground and that resistor to ground. Brilliant. Then we want the LED to come off this pin here, which is going to be the collector. That's got to go through a resistor and then into the LED. Right, that's easy peasy. So if we make a pad there and say there, and then we put in the resistor for the LED there, let's put 15k. This side of it's got to go into an LED, so we'll make this a surface mount LED. Which way is it going to go? This way, isn't it? Yeah, that's right. So this is going to be LED, so that has got to be connected to so, and then this has got to go to the positive, so we'll have to put the positive up there and bring that around there. Oh, and then we can stick the capacitor in here. Brilliant. So there you go. That will be a little surface mount sort of circuit of this thing here. Brilliant. And I guess we can make that about the size of a postage stamp. Now this is Max Marking, and this is the software that comes with one of the fiber lasers. What I've done, these are the surface mount components, and I'm just using these as templates. This rectangle here, that's basically going to be the space that I want to fit everything into. And then you're going to have the gate, the minus and the positive up there. So firstly, what I'll do is I shall copy and paste a line here and put it in between those two. Now what that will do is all this section will be left as copper and all this big section here will be left as copper, because I'm only marking what I want it to take away. So actually I think I might need another one of those. Let me just come in and drop another one down there, and then I can kind of line these up. So if I burnt that off now, I would have to highlight all these and stick them together. If I burnt that off, I should be left with 3 strips of copper inside a whole copper board. Now what I need to do is kind of figure out that I need to put a resistor around here, just in there. So to do that, I've got to remove the copper underneath the surface mount resistor. So therefore, I just draw in here another trace. Let's do another one of those anyway. Draw in a trace there, and it's going to cut that piece away. And then what happens is the surface mount resistor sits there, and that will connect this piece of copper to this piece of copper. You get the idea, I'm sure. Now, the difficult bit is working out when it comes to the transistor here. So I'm going to need another cut here, but if I take that right along there, like so, then when I drop a transistor in there, you see the legs, that will be in this copper, that will be in there where the minus is, and this will have a big piece up here, which I'm going to play about with in a moment, because I've got to put the LED and another resistor over here. So yeah, at the moment all looks good. Drop that in there. Now the only problem is I actually need another resistor here, and they're going to be too close, so I've got to jiggle around a little further. Maybe if I pull that back a little, I don't want to go too far, because I want to leave enough copper here to be able to solder one of these pin headers on the end of it. So let's see where we are now. So if I put a resistor in there, will I have enough space to drop one there? Yeah, I will, but it's still a bit close. So let me move this along a little bit more and stretch that. As long as this overlaps into here, then I can make them all, I can make it work somehow. So that's going to give me plenty of space for that, and capacitor's got to go between plus and minus, so that can sit inside there. Still need something else. I've got to have a resistor here before it goes into the LED, so I basically just need another one of these. Copy and paste. I like making circuit boards out of my head rather than using a program to do it. I mean, that's great if you're doing really complicated programs, but if you're doing something nice and simple like this, it's like doing a puzzle. I kind of enjoy it. So let's put that transistor back in there. You've got to imagine this is going to be copper, and then if we put that resistor here and then the LED on the end there, now the circuit is starting to look the same. capacitors, 3 resistors, transistor, LED. Great, brilliant. I'm happy with that. Now what we do is we start clearing the board, if you wish. So now I can remove these, and I'm happy where all those lines are underneath. So take all those out of the way. Now, I have to fill all this in and make it all connect with each other. So what you do is you highlight one of them and you want to modify it. You want to modify it by welding it to something else. So if I click that one, and just move that out of the way so you can see what's happened, that's made one piece, okay? So that's going to be one laser shot. It's going to do all that in one go. So now I want to weld this. Basically I've got to do it with all of them. Weld it to that. I can then weld it to that. So you imagine all the white is a piece of copper and all the black is what it's taken away, and that hopefully will make a tiny board so that I can place these components on. So over to the laser. Okay, now everything's sort of sat in place, and if I use a preview, it should be about the size of that red rectangle. That gives you an idea of where it's going to cut. So if I just place that there, like so. Oh, come on, stay still. Right, and let's cut, see what happens. Well, there you go. Now test it with a multimeter to make sure that's going to be okay. So the good thing is, at least I got the track widths correct, because then this little pin header will just solder onto there and I'll be able to just plug it into something and see if it works. That's better. So let me check. From the gate to the minus, no connection, no connection. This is looking good. Okay, there you go. That is the circuit. I'll come up to the camera a little bit more. I don't know if I can get that to focus. Yeah, there you go. That's not too bad. That's about 1.5 centimeters long, and I was just cutting it with clippers, so it's kind of cracked the board a little bit, but it doesn't matter as long as the copper traces are in place. Now, if I've done this correctly, it should work. Now, I've also put a 3mm LED facing that way, so that it can stick through a tiny hole above a jack socket that you're going to plug the gate into. So therefore you'll be able to plug the gate in there, and this will be sort of sitting on the top, and there'll be a small hole for that. So when there's a gate signal, the LED will light up just above the jack plug. Hopefully, that's the idea anyway. But it's small and it's neat, and if it works, I can make hundreds of these easily. Now I've done all the work for it. However, does it work? That's what's important. So, I'll take the Vactrol piece off this for now. We don't need that. Just unplug that and take that away. So this is the normal circuitry. Let me switch that on again. There you go. Right. So what's happening? Like I said earlier, I've got a signal coming in here as a gate signal. I've got 12 volts coming in there. So which is the gate? So it's gate minus then positive. So, oh, that's good. Well, at least the gate is there. Gate minus positive. So we want a positive on that side and a minus in the middle. Right, if this doesn't work, it doesn't matter. It's not the end of the world. The basic idea anyway was to say, you know, can I make a little circuit board with the laser that I've got? So now if I plug that in, is it's right, we're around gate minus positive, yeah. So if that goes in there, it should emulate exactly what this circuit's doing. So now there's two circuits. Let's see what happens. Ah, nothing. Oh, it's blipping. Why is it blipping? Gate minus positive. No, no, is that correct? It says it's me. It's this Y here. So yeah, there you go. It's working. Brilliant. So there's an LED gate signal, and there's an LED gate signal. Excellent. Well, I'm happy with that. So there you go. It all fits nicely onto the side of the jack socket. So I should be able to, with any gates in the future, just build this little circuit, put that on top of it, and then I'll have a signal showing me visually that there's a gate signal happening. Now you might think, what's the point of this? If you can put a gate signal in there with some power, surely you can just run it to an LED and get the LED to light up. Well, yes, you can, but to power that LED, you're going to be pulling some of the signal away from the gate. So if you've got a gate signal and it's going into A, B and C, several different things, and you start putting LEDs on them, then you're going to be lowering the voltage or current or whatever, and actually affecting the signal. Whereas by doing it this way, it shouldn't affect the signal at all, because all it's doing is the transistor is sensing that voltage, and then that's doing the switching to turn on the LED, therefore saving your gate signal. Well, kind of something like that. Anyhow, thanks so much for watching. All the best. Bye-bye.